Optics is a branch of physics that studies the behavior and properties of visible light. It can be subdivided into two parts, that is, one ray optics and two wave optics or physical optics. First of all, we should know what is light. Human eye is a nature's gift to us. The human eye or retina has the sensitivity to detect the electromagnetic radiation of wavelength range about 400 nanometers to 700 nanometers of electromagnetic spectrum is known as light. In that wavelength range, there are 7 colors from violet to red. From our common experience, we can mention two things about light. First, that it travels with enormous speed. Second, that it travels in straight line. In Newton's corpuscular model of light, he assumed that the corpuscles of light were massless elastic particles travel in straight line with enormous speed. After some years, people realized that the speed of light is not enormous but finite and is measured, and the speed of light in vacuum is 3 into 10 to the power of 8 meters per second. Another thing, that light travels in straight line contradicts the view that light is an electromagnetic wave. Hence, ray optics is valid when the wavelength of light is very small compared to the size of an obstacle, that is, the object that we encounter. Now we discuss about ray optics. A light wave can be considered to travel from one point to another along a straight line. Joining these 2 points, the path is called a ray of light, and a bundle of such rays constitutes a beam of light. In this chapter, we study some phenomena like reflection, refraction, and dispersion of light using the ray picture of light. Now we know about reflection of light. When light ray incident on a reflecting surface like mirror, it gets bounced back without getting absorbed by the mirror is known as reflection. Now, refraction of light. Refraction is a phenomena of light in which the ray of light entering from one medium to another changes its direction at the interface of the two media. Now we know about Snell's law. When a light ray travels from one medium to another, then the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant, called the refractive index of medium 2 with respect to medium 1. When a light ray traveled from a rarer medium to denser medium, refracted ray bends towards the normal. On the other hand, when a light ray travels from denser medium to rarer medium, refracted ray bends away from the normal. Now we discuss about critical angle and total internal reflection. When a light ray travels from denser medium to rarer medium, it bends away from the normal. That is shown in green. If the angle of incidence increases at particular angle of incidence in denser medium, refracted ray just grazes the surface at the interface between the two media, shown in red. This angle of incidence is called critical angle. If the angle of incidence is increased further beyond critical angle, refraction is not possible and the incident ray is totally reflected into the same denser medium that is shown in blue. Once again, we recollect the definitions of critical angle and total internal reflection. Now, critical angle. The angle of incidence in denser medium for which the angle of refraction in rarer medium becomes 90 degrees is called critical angle. The relation between critical angle and refractive index is n is equal to 1 by sin c. Now, total internal reflection. If the angle of incidence in denser medium is greater than critical angle, there are no refracted rays in rarer medium. All the light is reflected back into the same denser medium. This phenomenon is called total internal reflection. Application of total internal reflection. Formation of mirage. On hot summer days, the air near ground becomes hotter and the hot air acts as rarer medium. The cool air in upper layers acts as denser medium. If the angle of incidence in the air near the ground is greater than the critical angle, light ray from taller object like tree traveling from denser medium to rarer medium undergoes total internal reflection. The observer naturally assumes that light is reflected from a pool of water. Such an optical illusion is called mirage. Now, one example problem on critical angle. A ray of light passing through a medium meets the surface separating the medium from air at an angle of 45 degrees and is just not refracted. What is the refractive index of the medium? The solution. Given that the critical angle C is equal to 45 degrees, refractive index n is equal to 1 by sin C, that is equal to 1 by sin 45, that is equal to root 2 or 1.414. Now, you should know what is optical density. Optical density of a medium is different from its mass density. It is the ratio of speed of light in two media. It is possible that the mass density of an optically denser medium may be less than that of an optically rarer medium. For example, kerosene and water. Mass density of kerosene, that is 0.81 grams per cc, is smaller when compared to that of water, that is 1 gram per cc. But optical density of kerosene, that is 1.44, is high when compared to that of water, that is 1.33. Next, we discuss about refraction by lenses in next class.